question 1 part H, the last part of this question this is F. We've got a equation given for the volume of our square pyramid. We've got that the rate of the volume changing with respect to time is -6 centimetres cubed per minute. We've got that the surface area is going to be whatever that base. This is the base for the square pyramid. If I kind of think about it like that's the base, if you like, and we've got a square pyramid coming down. I'm calling this B and this H. And so the surface area of the square at the top is just going to be B squared. I can differentiate that to get ds dB, which is 2B. And what the question asks us is, what is the rate that the surface area is changing with respect to time when H is 12? Now, looking at the diagram, when your height was 90, the base is 30, so there's a proportional relationship between height and the base, and the base is just a third of the height. So this relationship between the base and the height is going to be a crucial one. That the height, this is 3 times whatever that is. Whatever the height, whatever the base happens to be, this height will be it will be 3 times that base. Okay, so now we've got H is 3B, we can differentiate that as well. dH dB is just 3. Now, in order to find ds dt, there are lots and lots of ways to do this. I've set up a fraction relationship, so if I want ds dt, I'm going to want ds in the numerator, and then whatever is in the denominator cancelling out, so the dB is going to cancel, the dH is going to cancel, and dV is going to cancel. So I'm left with just ds over dt. I'm doing that because I've got a whole lot of information that's going to be useful to me. I've got this dV dt, I've got that, so where's my dV dt? I've got this given to me in the question. I'm trying to find that's what I'm trying to find. I've got this ds dB, and so that's that one there. I've got this dH dB there, and that's just the reciprocal of this, so I've got that. So all I've got to find is this dH dV, or dV dH, and then find the reciprocal in order to find ds dt. So if I substitute into my volume equation from up here, the fact that B is equal to h upon 3, so replace that B with an h upon 3 from this relationship and simplify, I get volume is just in terms of one variable rather than 2. I can now differentiate this with respect to h, and I get h squared over 9. So that gives me the final piece of this puzzle, and so I should have ds dB, which is 2b, and dB dH is just 1 over 3, dH dV, down here we had dV dH, so just flip this upside down, we have 9 over h squared, and then dV dt, they gave us in the question, is -6. So now -6 multiplying through and just tidying up, we end up with, what can we cancel here? Let's cancel that with that. So we've got 2. So we've got 4 times 9 is 36b on top, and we've got an h squared down the bottom. So we want to find, this is not the end of the question, we want to know what is ds dt, what rate is the surface area changing with respect to time when h is 12 and b is 4. And so when h is 12 B is 4, ds dt is just going to equal 36 times b, which is 4, divided by, we've got h squared, so 144. I need to do that on our calculators, I think, which should give us the right answer.